So in this portion, we are going to study the cutting force. Okay. The major factors required for cutting force are length, sheet thickness, and shear strength. Okay. First of all, length is a peripheral length. Okay. So if you consider this is your as a this circle as a cutting portion into the stock material. So this circle is having a diameter of 10 mm. Okay, so what is the peripheral length? You can directly calculate the peripheral length by using the formula pi d. Okay, so 3.142 into 10, that is 31.4 sorry 31.42 mm is the peripheral length of this circle. Okay, consider another example. Okay, a square block which is having 10 mm each side. Then what is the peripheral length? 10 into 4, that is 40 mm is the peripheral length. So L is the peripheral length of the given drawing. Okay. Next is sheet thickness. Okay. So minimum the sheet thickness, lower will be the cutting force. Higher the sheet thickness, greater will be the cutting force. Okay. The similar thing happens with the length. Okay. Higher the peripheral length, more will be the cutting force, and lesser the peripheral length, lesser will be the cutting force. And lastly, the tau max, which depends upon the material. Okay. So if you consider mild steel, okay, this is having higher shear strength as compared to aluminum. Okay. So if you consider the material, the shear strength will be different for different materials. Okay. So for the same size of peripheral length, for the same size of the sheet thickness, for a given operation, if we change the material from mild steel to aluminum, the cutting force will change. Okay. In general, this shear strength for a mild steel is around 400 Newton per mm square. Okay. The shear strength for materials is different as compared to this aluminum and cold rolled steel. Aluminum is approximately 50% of its tensile strength, and cold rolled steel is approximately 80% of its tensile strength. Okay, for stainless steel it is 90% of its tensile strength. Okay, so again, press force. Okay, what is this press force? Press force is the summation of cutting force and stripping force. Cutting force that we have calculated above. Okay, that force required to cut the material from its stock. Okay, and what is stripping force? Stripping force is a force required to hold the stock material on its position. Okay, that means when you are going to hold the workpiece or the stock material at its position while cutting, the force which required for that is a stripping force, and it is generally 20 to 20% of the cutting force. Okay, so next portion is steps to reduce cutting force. Okay, so whenever the force has exceeded the minimum value, what happens? We require to reduce the cutting force. Okay, there are two methods to reduce the cutting force. The first one is stepped punches. Okay, and the second method is grinding the face of the punch or die to a small shear angle. Okay, first we will consider stepped punches. Okay, in the stepped punches you can observe three punches are there. Okay, in a single operation, in a single stroke, we have to perform these three operations, that is first, second and third operation. Okay, in this three operation, you can see the length of the first punch is greater than second, and the length of the second punch is greater than the third. That means we have make a stepped arrangement of the punches. Okay, because of this, what happens, a gap is generated between the punches. Okay, and because of this, the first punch will perform the cutting operation. Okay, after which the second punch will perform the cutting operation, and after that third punch will perform the cutting operations. Okay, that means in a single operation, in a single stroke, we have divided the operation. Okay, that means this is the first operation, that is this is second, and this is third operation. Okay, now grinding the face of the punch or die to a small shear angle. Okay, if you observe this figure, in this figure, what you are observing, the grinding has been performed on the surface of either punch or die, or on the both punch and die. In the first case, this is first, this is second, and this is third case. In the first case, there is no shear angle. Okay, that is, the surface of the punch is exactly horizontal and flat. Okay, but in case of this die, a small shear angle has been provided on the surface. Okay, the grinding has been carried out in order to get the shear angle. Okay, you can observe this shear angle. Similarly, in second figure, shear angle is provided on the punch surface. Okay, this is shear angle. Okay, sometimes, as we have shown in the third figure, that shear angle can be given to both punch and die. Okay, so this is shear angle. Okay, what is the purpose of this providing the shear angle by means of grinding? Is that whenever you are performing the operation, the force get reduced. Okay, so how does this force get reduced? If you observe carefully that, consider this is a punch. Okay, and this is a die. Okay, and a stock material has been placed over here. Okay, this is a stock material. So you can clearly observe that this is a shear angle provided to the punch. When the operation, when the ram is in downward position, what will happen, the this portion, okay, this portion will enter or will penetrate into this material for the first time, and then the portion on the other side, the other edge, will penetrate at last. Okay, that means step by step, what will happen, the material will penetrate into the, or the punch will penetrate into the stock material. That means we have distributed the load gradually over the punch surface length. Okay, along this length we have distributed the force. Okay, initially from this portion the force will exert. After that, this is how the force will exert. Okay, similarly happens with the die case. Okay, punch case, and both punch and die case. Okay, so this is providing or grinding the surface in order to provide the shear angle. Next is cutting clearance. Okay, what is mean by cutting clearance? When you consider, so consider this is a portion we have to consider this is a portion we have to cut from the stock material. So we will take the punch of this size, but while considering the die, there will be some gap between punch and die, and this gap is considered as a clearance. Okay, this is a clearance. Now, how to calculate this clearance? Clearance can be calculated by using formula clearance is equal to C into T into under root tau max divided by 10. Okay, so in this case, this C is a constant which is having value 0.005 for accurate component when you are going for a finished product. Okay, so for a normal component where you does not require more accuracy, you can go C value as a 0.01. Okay, so this is a constant value, we can take as a 0.005 or 0.01. Okay, into T. T is the sheet thickness. Okay, and lastly tau max divided by 10, under root tau max divided by 10, which is shear strength. By using these values you can calculate the clearance. Okay, and by which you can design punch and die. Okay, generally clearance is